I have got a challenge for you to start off today's lesson. So we're going to focus today on what's called a rational exponent. You can also call it a fractional exponent. But look at these numbers over here. 10 to the 3/2 power, 10 to the 1/2 power, 10 to the 4/3 power, 10 to the 3/4 power. What in the world does it mean if you have a fraction for your power? 10 to the 3/2 power. What in the world would that mean? Well, I'm gonna set up a little challenge to see if you can kind of figure this out on yourself first before we take our notes. In today's lesson, we're gonna take a bit of notes. I encourage you to get out a separate sheet of paper. But then the last half of this video, I'm going to do some examples right off of your assignment. But I want to see if you can match. I want to see if you can match this column with this column, and you can use your calculator to help you out. So, for example, let's kind of review on a calculator. How would we find a number like the 3rd root of 10 to the 4th? Well, every calculator is a little different, but generally on the calculators, you're going to start by typing in your 3, and then you're going to look for some type of X radical button. Now, in my case, it's a second caret. And you'll see how this gives us a little X radical sign. This means take the 3rd root of 10 to the 4th power. That would be 10 caret 4. Now, I'm not going to write out this whole answer. It is irrational. But I'm going to write just 21.54 approximately is what this one is equal to. Okay, and so I would encourage you, go ahead and do that for the rest of these as well. Now let's look at how we would do this with our fractional exponents. 10 to the 3/2 power. The way I can type this in, I'm going to hit 10 caret, and then inside a set of parentheses, I'm going to write 3 divided by 2. So 10 to the 3/2 power in our calculators, we can do 10 caret 3 divided by 2. So this one comes out to approximately 31.62. I want you to hit pause on your video now. Go ahead and try these. Write these out. Kind of find the corresponding decimals. And ultimately, I want to see if you can match these together. And I want to see if you can come up with the relationship between the roots and the fractional exponents. Hit pause now. Let's see how you do. All right. Well, here's the values I hope you got in the calculator. Let's start matching these up. Here I have a match. The 3rd root of 10 to the 4th matches with 10 to the 4/3 power. Interesting. Look at that relationship there. What do you notice about the 3 and the 4? This 4th root of 10 squared matches with 10 to the 1/2 power. This square root of 10 to the 3rd matches with 10 to the 3/2 power. And then our bottom two match as well. This 4th root of 10 to the 3rd matches 10 to the 3/4 power. Well, I hope the relationship is kind of obvious. Look at what happens here. Notice that here I had an exponent of 4 and a root of 3. And look how it matches. This fraction, the exponent of 4 gets put in the numerator of the fraction. This root of 3 gets put in the denominator of the fraction. And listen, that's actually the connection. We can say the power, whatever the exponent is of our root, of these numbers on the left column, the power becomes the numerator of the fraction, whereas the root becomes the denominator. And that actually holds true in all of these examples. So it's real obvious here as well. Here we have a power of 3 that becomes the numerator. Here we had a denominator of 4, a root of 4 that becomes the denominator. Okay, now let's look at this one. This one you might be able to argue a little bit. Hey, what's going on here? But think about this. The 4th root of 10 squared. If we could take this power of 2 and write it as the numerator, and this root of 4 and write it as the denominator, we'd have 10 to the 2/4 power. Well, 2/4 is a fraction that actually simplifies to 1/2. So this relationship holds true. And then lastly, we can look at a square root. I'm not sure if you're aware of this, but a square root actually does have an invisible number right here. With any square root, there should actually always be an invisible 2 in this location. So here we have a power of 3. That becomes the numerator of my fraction. And we have a root of 2. That becomes the denominator of my fraction. So keep this relationship in mind. Let's actually take the time right now to review all of our rules of different types of exponents you can get. And we'll end with our rule of rational exponents, the highlight of these notes. But let's review. What happens if you have a positive exponent? What does 5 to the third actually mean? Well, remember, that means 5 times 5 times 5. Okay, that would give us an answer of 125. An exponent just tells us how many times to multiply a number by itself. Okay. Now, what would an exponent of 0 mean? An exponent of 0 actually always equals 1, no matter what. No matter what your base number is, if you take it to the 0 power, the answer is always 1. Now let's talk about a negative exponent. What if we have 5 to the negative third power? Well, this actually, believe it or not, this means take the number 1 and divide it by 5 3 times. This is dividing 3 times is what it means. Now the way it's written, we actually write it as what's called a reciprocal. Anytime you have a negative exponent like negative 3, you can always write it as its reciprocal, 1 over 5 to the positive 3. But this really just means take the number 1 and divide it by 5 3 times. Now we could write it as this fraction. It's 1 divided by 125. That's how we'd write it as a fraction. All right, so now let's make the rule. This is the moment we've been waiting for. The rule for rational exponents, or fractional exponents, you can also call them. What we would do is the denominator of this fraction would become our root. This would mean the third root. The power of this, the numerator of this fraction would become our power, 5 to the first power. This means the third root of 5 to the first power. This means what number times itself 3 times would give you 5. Now I don't believe this comes out cleanly. The third root of 5, yeah, it's irrational. It's approximately 1.71. Here's all that means. If I do 1.71 times 1.71 times 1.71, I will get approximately 5. So that's what a 5 to the 1/3 means. Here's the rule. If you write nothing else down out of these notes, this is the rule I want you to know. With any base number that has a fractional or rational exponent, the m, the top of that fraction, becomes the power, and the n, the denominator of that fraction, becomes the root. And I want you to realize this rule also holds true with various types of parentheses. Even if the b is in parentheses, b to the m over n power, or even if like your root is in parentheses, this would mean the same thing. This is also just as true. Okay, so let's use this rule now to answer questions right off of your assignment. This assignment is fairly lengthy with over 20 questions, but a lot of these are really quick hitters. So number 1, the simple answer is it has a root of 3. That's going to become the denominator of my fraction, and it has a power of 4. That's going to become the numerator of my fraction. The answer is C, into the 4/3 power. Now, if you really want to get fancy here, you can do this whole thing where you say, well, m is equal to 4, and n is equal to 3, so it becomes n over 4 to the 3rd. Okay, but really, I think that's a pretty obvious relationship there. I hope you can find that quickly. Just a reminder, as you get to the other problems in this section, be aware of invisible numbers. A square root, this has an invisible 2 right there. Now, if your problem doesn't have a power at all, remember you can always put an invisible 1 right there for your power. So keep that in mind as you finish this section. Now moving down to the next section, you can also do this in the opposite order. So again, here you have b to the 3/2 power. Well, if you want to get fancy, you can say, well, the m is equal to 3, and the n is equal to 2, and then you can go back to your whole relationship that we had in our notes, kind of lay it out like this. Okay, but ultimately, I think once you see the relationship, this is very easy. My answer is going to be right here because there's an invisible 2 here. This has an n value of 2 and an m value of 3. All right, so that is that section. The one thing I will caution you on in this section, remember with the negative exponents, you would have to write it as its reciprocal. So I can tell you right now, when you see a negative exponent, the answer is either going to be A or C. Here we see a negative exponent, the answer is either going to be B or D. All right, on to the next section. All right, 9 through 12 says simplify. You may use a calculator. Let's do one of the trickier ones here. Let's do number 11. 25 to the negative 1/2 power. So I'm going to do 25 caret, and then in parentheses, I'm going to do -1 divided by 2. Okay, this is 25 to the -1/2 power. Now you notice here using my calculator, this answer comes out to 0.2. And that initially does not look to be one of my choices. But just, you can convert these fractions into a decimal. 1/5, if I take 1 divided by 5, that is also 0.2. So you can see the match here. The answer to this one's going to be A. Another section is, I think it's the trickiest section, so we'll take our time on it. 13 and 14 are very similar. Let's actually look at 14. Before we start 14, I want to go over a rule with you. If you multiply a variable, and that variable has an exponent, like this is x to the second power, or times x to the third power, so both of these variables have the exponents, 2 and 3. The rule is you would actually add those exponents together, and this would become x to the fifth. Now this rule makes sense because, you know, x squared is just x times x. X to the third is just x times x times x. Well, multiply all those together, what do you get? You have 5 x's multiplied together. That's x to the fifth. So let's use this rule to help us with question 14. So I'm going to put a little 1 here next to this x. So we're going to start here. We're going to actually multiply our coefficients together like normal numbers. 3 times 2 times 2, that's 12. Okay, so I just do that. 3 times 2 times 2, I get 12. And yeah, by the way, that actually gave away the answer. That made that really easy. But ignore. I want you to understand what's going on here. With our powers, however, x squared times x to the first times x to the 1/4. To find our powers now, we're going to actually have to add 2 plus 1 plus 1/4 to find our power. Now, 2 plus 1 is 3, so really I have to do 3 plus 1/4. Now, as a mixed number, that would be 3 and 1/4. Let's actually write this as a improper fraction. The 3 over 1, if I want to get a matching denominator here, I'd have to multiply the top and the bottom by 4. So 3, another way to write 3 is you can say that it's 12 over 4. And then 12 over 4 plus 1/4, you add the 12 plus 1 is 13. You keep the denominator 4 the same. So ultimately, this becomes 12 times x to the 13/4 power. And that's exactly what we get. So for questions 15 and 16, we need to review another old rule. And by the way, reviewing these old rules, man, this is great practice for like standardized tests, ACT type tests, things like that. So this is good practice for us. So the rule, we'll do 16 together. The rule we need to review though is if you ever have a power to a power, like here we have x to the second power, but then all of that is to the third power. And the rule is if you're ever taking a power to another power, the rule is that you would multiply those powers together. This would become x to the sixth. Okay, so with that in mind, the rule here, this is going to become v to the 1/4 times 2/3 powers. Now when you multiply fractions together, you do not need a common denominator. When you multiply two fractions together, you can simply multiply the numerators. 1 times 2 is 2. Multiply the denominators. 4 times 3 is 12. And then cut both of these numbers in half. This reduces to v to the 1/6 power. Likewise, before we can do questions 17 and 18, we need to remind ourselves of a rule on how you divide two variables with exponents. So here, if we're taking x to the third power divided by x to the second power, the rule here is that you actually subtract those exponents. This becomes x to the first power. And this makes sense because in essence, if you have 3 x's on top of a fraction and 2 x's being multiplied on the bottom of a fraction, those x's are just going to cancel out and leave you with a single x. Okay, but let's use this rule now. Let's use that review to help us answer question 18. So here, the coefficients I'm going to just treat as normal numbers. 3 divided by 4, well, that can't be simplified. I'm just going to leave the fraction 3/4. And by the way, yes, they made this really easy. They're giving away the answers. Okay, So that made that really easy. But I want you to understand what's going on with the rest of this. Now to find the n, we're going to have to subtract 2 minus 1/4. Okay. Now 2 minus 1/4. If I want to get to subtract fractions or add fractions, you do have to get a common denominator. So I'm going to write this as 2 over 1. I'm going to multiply the top and the bottom by 4 so I can get this lowest common denominator of 4. You see 2 can actually be rewritten as 8/4. And then 8/4 minus 1/4, I subtract the 8 minus 1 is 7, but I keep the denominator of 4. This is going to be, final answer, 3/4 times n to the 7/4 power. And you can see how that matches perfectly. Now, you can use these rules that we just learned, particularly this power rule here, the power of a power. You can use these rules that we just reviewed to easily be able to solve equations that have rational exponents. So here we're asked to kind of like fill in the blank. 3 equals blank to the 1/4 power. Okay? Well, let's think about this for a second. If I want to solve for b, a really clever way you could do this is I'm going to multiply both sides of this equation by the reciprocal of 1/4. I'm going to multiply both sides of this by 4, or 4 over 1. Okay, so over here, 3 to the 4 over 1 power. You can just write that as 3 to the 4th power, same thing. But watch what happens over here. If I take b to the 1/4 power to the 4 over 1 power, well, think about it. I would have to multiply. This would become b to the 1/4 times 4 over 1 power. Well, look, all these cancel out, and I'm just left with b to the 1st power. Or in other words, I'm left with my solution. b is equal to 3 to the 4th power. Get out my calculator. 3 to the 4th power is 81. Final answer, 81 is equal to b. Okay? The way you kind of cancel out this 1/4 power is you take it to the 4th power, or the 4 over 1 power, and you do that to both sides. So the solution is pretty simple. It's just 3 to the 4th power. Likewise, I don't want to give away like the answer, but likewise, to solve this, I'm going to take both sides to the 2/3 power. And my 2/3 power and my 3/2 power, when I multiply them together, those will cancel out. And m is just going to be, this is what I have to evaluate in my calculator, 343 to the 2/3 power. That, I'm not going to tell you the answer, but that would give you the answer. Okay. Now down here, these have a couple of steps. It's the same idea though. Here, I'd actually have to subtract this 10 from both sides first. And n to the 3/2 power equals 729. But the way I get rid of a 3/2 power is I take it to its reciprocal power. I'm going to take it to the 2/3 power. Now I have to do that to both sides of the equation. But ultimately, when I multiply these together, you'll get 6 over 6, which is just 1. You can say this is n to the 1 power if you want, or you can say those just cancel out. My solution here is going to be 729 to the 2/3 power. Comes out nice and clean. It comes out to 81. So likewise, I don't want to give you the answer on this last question here, but this one, the x minus 10 being in parentheses as it is, you're going to start this one off. You're going to take both sides to the 2nd power, or the 2 over 1 power, the 2nd power. And those will cancel out. You'll be left with x minus 10 equals 25. And hopefully you know what to do from there to solve for x. Okay? All right. Hey, I know this was a long lesson, a complex lesson, but that's why I wanted to make sure I did problems right off the assignment to try to help you out. Best of luck on the rest of this assignment. Let me know if you need any help. Bye.